the appeal what graphene has is that you can use it as an ultralight material for airplanes. At the same time, you can use it as a membrane for example, filtering water, desalination. At the same time, you can look at in the IT that there's an opportunity to look, for example, new energy storage. I mean, the range is ubiquitous, and there's so much potential out there. The question is, who is going to grab on that potential?
Chalmers University of Technology has been honored to coordinate one of the European Union's biggest ever science project, Graphene Flagship, and time has come to take the supermaterial out from the research labs and into everyone's lives.
Chalmers has a proven record of the research in nanotechnology. Its clean rooms are used widely across Europe by many of our colleagues. It has a very active team both in administration and in science. So far, I think it's been a lot of work, and Chalmers proved that you are up to speed with this.
The method Jie Sun and his colleagues in the Quantum Device Physics Laboratory used to fabricate graphene is called CVD, chemical vapor deposition. This method and the state-of-the-art cleanroom facilities at Chalmers opens up for scalable and high-performing solid graphene samples. The 50 micrometer thick copper sample must first be cleaned. After passing a few baths of different chemical solutions, such as acetic acid and acetone, the sample is finally blown dry by nitrogen gas. The foil is then loaded into the CVD machine. In a fixed position, it will now be heated to a temperature just below the melting point for copper, about 1000 degrees Celsius.
And then we introduce some gases. They contain carbon, such as this one. It's called methane. At very high temperature, these carbon gases will become graphene on top of the copper.
The idea was from the beginning we could not build flagships for the sake of science. So it can never be science for the sake of science. And this program, Future and Emerging Technologies, had always the mission to say, how do we deliver knowledge from science and aggregating knowledge in science towards radically new technologies?
Graphene is an extremely exciting material, and I think it was a natural choice to be chosen for the flagship.